Is it going?
Yeah.
Hi, Sam. Okay, so we have two kinds of waves. We have transverse waves and
Happy
longitudinal waves.
Happy Valentine's Day. Merry Christmas.
Okay, you just.
Sam, will you be
And
my
then
Valentine?
reaction for fun. Not a problem. We just fooled
doesn't
around.
pick me up on
Did she make
time.
your bike there?
No, she just gets home late.
Oh, because I was chatting with her last week. It wasn't called the
Exactly when we were supposed to be
Don't
going
smell it.
inside.
What?
She left exactly when we were supposed to come.
Yeah, it smells really bad. Don't
Can,
suck up a big
I
whiff.
can't smell it.
Ammonium nitrate form. You know, the product is ammonium hydroxide, and all ammonia things smell terrible like that.
Okay.
So, transverse waves would look something like this, if that was like the baseline.
Josh, will you be my Valentine?
I'm so bad at drawing
No.
things.
Please.
And longitudinal waves are more like a slinky.
I have some
Like this.
presents for you. I did 7 labs. Wow.
Holy moly. I haven't had time to do any labs. How does she do 7?
Thanks.
7?
That's a lot of labs. Good thing
Those
chemistry
are
didn't
all
turn
my
into
corrections, finally.
Okay,
None
so
Watch
a
her send them all
transverse
back.
wave.
I know.
The way that you
Probably
would
will.
describe a transverse wave with actual scientific words would be a transverse wave oscillates.
Oscillation is perpendicular to its propagation.
Okay, that's annoying.
Oscillation is perpendicular to its propagation. Okay, so what does that mean? What does oscillation mean?
Josh. It goes up and down.
Yes, up and downness. Okay, oscillation.
Waves.
Uh-huh.
This chapter was really fun.
Yes.
It is really
I was
cool.
like, this is such a fun chapter.
So
Talks about
oscillation
waves
is
and all I
going
can think
up and
about
down.
surfing.
It's perpendicular to, in the shape of a T. It's propagation. Propagation is the direction of travel. Okay? Oscillation is perpendicular to propagation, means it goes up and down in a way that's perpendicular to the direction it travels. Okay? So if it's traveling this way, it's oscillating this way, perpendicular to it.
So that's transversive.
Transverse wave. A longitudinal wave has an oscillation that is parallel to its propagation.
Like this.
Right.
Yes,
So exactly like that. If it's traveling this way, it's oscillating in that same exact direction that it's traveling. So, my drawing is so bad. But if you think, here's a spread out area, here's a bunched up area, here's a spread out area, here's a bunched up area, then that would be just like the crests and troughs that you're more familiar with the transverse wave. So let's label our transverse wave first, because most people have done this in like middle school science or whatever. Okay, so what would the tippy top
The crest.
crest and the bottom?
The
Trough.
trough.
Aw. I thought it would be the band. I
And
didn't know.
how about the distance here?
Amplitude.
Amplitude. We'll call it amp for now.
Can it be also the distance, like, on the bottom too?
And it should be equal for
Just like your
this
mass
type of
range
wave.
system.
Yeah, I know.
Yep.
I wrote it for both. I
And
just
then
researched it.
how about this distance here?
Wavelength.
Wavelength, lambda.
Lambda. I'll look that up.
I like that it's a lambda.
How
I
about
love
how
lambda,
many,
like-
like let's say here's the point that we're measuring. How many crests pass this point per second? What would that be?
Frequency.
Frequency is crests per second.
Measured in hertz.
Uh-huh.
Not to be confused with times.
Right, because you end
I
up
like
with a unit that looks like 1/seconds, which is a hertz.
Cute.
So in the less familiar, slightly less familiar longitudinal wave, you also have similar things. You have an amplitude, right? Like the size of the wave,
It's in between.
right? Okay, you have crests and troughs to some extent. You have places where it's more bunched up. Does anyone know what those are called?
Compression.
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 That's right.
And how about spread out?
Rarefactions.
Rarefaction. Rain.
Rarefaction.
Rain. Wow. Rain.
Spread out is
What are those
I
sounds?
don't even know.
Okay. And what other parts do we have? Do we have a wavelength?
Yes.
Yes. Okay, so
It's like,
from,
what, sir?
say, the beginning of one compression to the beginning of the next compression would be the wavelength. And how about frequency?
How many of those pass?
How many compressions per second, or rarefactions per second, or whatever. Compressions per second. Okay, so what very familiar type of wave would be a transverse wave?
Water.
Ripples in a pool.
Okay, so water type waves or transverse waves. What other very familiar wave?
What about like
Light?
Light. And that's our big
One of the
one.
questions was talking about like how light, it can, some people think that it's a particle, but it's, particle or a, wave,
It's
like
both.
but it's both. Yeah.
like
It's
the
like a particle wave.
like the little
Like the
comic.
little comic.
Particle
wave.
A wave of particles, right?
Oh.
Is it like a wave of
Yeah, and
particles?
nobody really fully understands this. At least
No
not
one
enough
fully
to explain
understands
it to me.
anything in this world.
No. Okay, so a
Yeah.
longitudinal wave. What's the most familiar type of wave that's
Sound.
longitudinal? Sound or slinky. That's all I've got example-wise.
But slinky,
We have
sling,
2 experiments.
e. That's funny.
Okay,
It's a
so,
slinky.
and here's
What are they
the
actually called?
longitudinal
Just-
wave propagating. So hold it out and
Slinker.
Is there any other name for a slinky?
Slinky Junior.
No, like
Uh,
That's what this is.
scientific
a
name for
spring. I mean, and
Yes,
it's just a
a,
giant spring.
That's the one we
has a
did
small
with
cake.
Mrs.
Small cake.
That, you know,
production
like
spray.
you know, they came
Mrs.
up with
Mrs.
slinkies like when my grandpa was a kid.
Garner.
Yeah.
Remember?
Probably even before
Well,
that.
sit
Springs
outside
have been
and we
around
had
like in
ours.
Boston.
No, actual
Boston.
slinkies
The
like
toy.
really sold.
Right, yeah.
Using it as a
Yeah,
toy.
they,
And hit us.
he said that like people like
With this
flipped out about them. They're like,
They're so fun. I had to
And it kind of
My
Same
kids
thing
break them
happened
really
with Rubik's
fast.
Cubes, only it was like
Okay.
50 years later.
So let's
Rubik's
talk
cubes are
about
dumb.
when
Okay,
you
it's all
have an actual light wave. What do you see if you look at the diagram? Okay, so the amplitude of a light wave, what does that correlate to in what you see in the light?
How bright it is?
Brightness. Amplitude is brightness for a light wave. And, poor Sam, I hope you can see that. Amplitude is brightness. How about the wavelength?
Speed?
The color.
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 The speed of light is, fairly constant in air.
So fast.
It's fast.
It's-
It's really, really fast.
They say that like
What other parts do you
the
have
speed of sound really isn't that
there? No,
fast.
sound isn't that fast.
Well,
Because
not
like,
really that
because
fast.
I'll be like, when you do the like, what do they say? Oh yeah, like when you shoot a gun, you don't hear it until like later.
If you're
When
far
you're
away.
when you're farther away.
Squeaky hit behind.
Yep, sound takes a lot longer to travel than light.
You'll hear
so
the boom. You're like,
Like,
what
that's
happened?
a-
That's why you hear thunder, or after you see the lightning. That's why you.
Or you
That's
get
how you know the
But that's
distance
the
Or you
away
get
is
shot,
by
you're
how
bleeding,
far
then you hear the
calculate
bang.
that
That's
I
it.
burn mine.
Like if you're far away.
Boom. Oh, that's it.
So.
Oh, that's what it
else do we
was.
have?
I like it out of my mouth.
How about frequency? What does the frequency of light tell us?
Oh,
What?
No, never mind.
What was
Square
the
velocity
question?
of a unicorn.
Frequency? Nothing that fun, right? But you can use frequency to calculate wavelength using this fun equation here, and then tell what color it is. So if you have frequency, you can get color, you just have to do a little math.
frequency is what makes it like X-rays. It's invisible light.
Well, X-ray is just like a color, except we can't see it.
Right.
But yeah.
Oh, okay.
We can see.
And like gamma rays
Okay,
and
so
other
light,
rays.
things like X-ray, radio,
Yeah.
microwave,
Yeah.
visible light, all that stuff is electromagnetic radiation, right? So,
yeah.
The
So
electro
you're seeing a
part,
little radiation right now?
yes.
What's
The
that?
electro part oscillates this way, and the magnetic part would oscillate perpendicular to that and also perpendicular to the
Wait, so you
direction of
have-
propagation. So if it's propagating this way, the electro and the magnetic part are oscillating like this.
Wait, so is it a little bit of both of them then?
All light is electromagnetic radiation. So you have an electrical wave and a magnetic wave traveling together perpendicular to each other and perpendicular to the direction of
Is that
propagation.
one picture?
Wait, those
Can
are
I
the,
say that any faster?
Ooh.
these gamma
Well, that makes
rays or
sense,
whatever.
They kill
Those
you.
are like, those are what kill people, right?
What?
Gamma,
Rays?
They can.
Yep. Gamma rays are dangerous.
Hey, have
They're
you,
like,
wait, why did, ask me, or, why did they have like these abandoned hotels and then they have these signs up on there that are like for like a nuclear looking sign or whatever?
Oh, they, in the 50s when people were afraid that Russia was going to drop the bomb on us and we were going to drop the bomb on them.
We would
like-
die if that happened?
Well, yeah, but
All of
practically
us?
every building,
Oh.
anyone within range, depending on how many bombs were dropped, and then people would get cancer at a higher rate, and it would be really bad.
Oh.
But there were bomb shelters in practically every public building, so if you do see the little nuclear symbol, it's just telling you where the bomb shelter is. So
Oh.
all buildings older than 70 years are probably going to have a bomb
Do we have bomb
shelter.
shelters here?
No.
I mean, like,
Yeah.
Maybe in
And-
the other building before they tore it down.
like what if,
You'd have to
what if
stay
some
in a
countries
That
did
one
that
was
to us,
only
what
like
would we
20
do?
years old.
Die.
That
We would
wasn't
die?
20
We
years
got
old.
base right next to us.
When I was
See-
a kid, the threat was real,
I mean,
like
it's been our
constant.
church
Like the
for
bomb
20
could be
years.
dropped anytime. You guys have never lived under the threat of like
Were you
Russia
guys scared?
is with their finger on the button. A few times, actually, one time when I was maybe 10 or 11, and I had just learned in school like how real the threat of nuclear, war was. And then I got home and I turned on the television and I saw this movie, and it was like a news report in a movie, but I didn't realize it was a movie. I thought it was just a news report, and they're like, Russia has pushed the button, all this stuff. And so I'm like glued to the
Are we
television.
good with Russia now?
And then they put on a commercial, and I'm like,
It's not real?
and I wasn't sure. It wasn't like I could go look online like you guys can today and see if there's real news going
Wait,
on.
did Russia really drop
I
the
know.
bomb?
Why
No,
would
they
there
have
be a
missiles
commercial?
that can
Like,
do bombs anymore.
well, yeah, but so yeah, the threat was real. Then
That's
you guys
so
have
crazy.
never like thought, oh, this is really gonna probably happen.
What would happen if like they were like, hey, we're gonna bomb you? What would we do? Bomb them?
Bomb them. That's why it never happened.
It would just
because they knew
ha-
they'd
But
What
didn't
would
they have
we would-
missiles that could like shoot it out of the air?
Ronald Reagan did make some effort. They called it Star Wars, and he did make an effort to
Was it before the
design
movie?
a response system, because nuclear weapons that are long range, enough to go from Russia to us, have to go up into space, right at the edge of space, and come back down. So our plan was to wait till they got there and aim and shoot and hopefully hit it, so that it didn't actually get to us while we were still.
Would we
That'd
be able
be
to do that
very
now?
precise.
Like if anybody tried to?
You better have some good aim.
Oh,
I mean, can you imagine being the guy that had to do that calculation?
you could kill all of
You
everyone.
do that now.
You have to hit it, and you get one
You know,
chance.
some people say
Maybe
that there are
somewhere.
bombs that could actually,
I just like
that
shoot
could
like
actually like wipe out like a majority of the
It's like,
United States.
wow.
If we dropped them
Well,
all,
this
we could
dumb
definitely
did
blow the
them.
whole Earth up. I mean, I think that there's enough nuclear weapons on Earth to blow up the whole Earth 7 times.
Oh my gosh.
Right, it's a big
See-
problem.
Josh, the acronym is MAD, Mutually Assured Destruction.
Yeah,
That's what they called it.
that's why it never happened, because they knew that if they shot the bomb at us, we were going to shoot back.
And
And-
then America is obliterated.
And then
Russia is
everyone would
obliterated,
be
and they gotta start
killed
all over
and-
from England with the Pilgrims again.
I don't know, I'm
Have to
thinking
wait
Brazil
several
would be
years.
world power at this point in history.
Yeah, that too. So
Then
unless you
not
want
so much.
Brazil
Or
to take over
Iran.
the world, you better.
Well,
go
what
for
if like a bunch of countries are like, all right, well,
China.
we don't like the
China.
United States anymore. Let's just kill everything.
Well, when I was a kid, it was just Russia and America had the bomb, and that's it. Now everybody's got a bomb. And
So they could be
Hey,
like,
I have
hey,
my little
you
bomb.
and me, we're gonna
And
all
when,
get together and
when
we're gonna
Russia
kill the
broke
United
up into the
States.
Russian Federation, now it's like what, 20 countries or something that used to be
I'll just start
USSR,
swimming.
and they all had nuclear facilities. So now all these crazy little tiny countries may or may not have nukes or the ability to make them, and we don't even know. And then they all sell them to Iran.
Have you heard about Iran's nuclear facility under the huge mountain and how they're trying to build like a weapon big enough to blow up the mountain
Or blow up Israel.
or that?
And that's
no,
not good.
like United States, not
If
Iran.
Israel gets blown
Like,
up,
blow
wouldn't
up their
Jesus come back?
facility.
That's
Not
Yeah.
necessarily, but I mean there is real danger. Iran's crazy. India and Pakistan have them. That's not good. But anyhow.
what is the
So
Back
getting
to
back
real
to light
life.
rays.
Back to the important stuff, people. No.
Sorry.
To slinkies and
Um,
sound.
Okay, so slinkies are like sound waves. So what is the amplitude on a sound wave going to do?
It's gonna make me sound louder.
Okay, so volume. Amplitude is volume for a sound wave. And what tells us about pitch?
Wait, so
Frequency.
Frequency tells us about pitch. It was down here. Frequency tells us about pitch. Okay. So, what else? Is there anything else I'm supposed to tell you about that stuff? No, probably not. Okay. So, when sound of a certain pitch is moving in relation to you, so that can look like the sound is moving like a car, or the sound is stationary and you are moving, then you experience something called the Doppler effect, when a constant pitch appears to change because of its motion in relative terms to the listener. Okay, so next week we'll do some experimenting with that. We'll do some math hopefully this week. But we're going to do a lab, and we have to figure out how grossed out you guys are going to be about blowing across a pipe that somebody else just blew across. So I have to plan for this.
we all get to
so-
kiss each other. Yay.
Okay, so who has any flute type playing experience, blowing across soda bottle type experience? Christina? Anyone
Wait,
else?
what'd you say again?
Across
Say
the
it
bottle experience. Do you
I
mean
played
like I tried it?
trombone.
Can you
Fourth
make a
grade.
noise?
Yeah, that's
successfully?
easy. Like,
Yeah, I
Possibly.
can make a noise.
Yeah.
But it
Yeah.
was like.
I used to
Yeah.
play the trumpet.
I played the trombone in 4th grade.
I can play the trombone.
I used to tie my shoe when.
my brother and I
I
used to
love
think we could make a band out of like soda bottles blowing, and like whoop doop, and we'd all go up to my mom and she'd say we were terrible.
Well,
We'd stop.
you could get better if you.
With pants,
Yeah.
too.
Okay.
Well, we all were sort of playing the same note.
Ouch. You gotta change the amount of liquid in the bottle.
Well, that's hard to do.
Hey, what I used to
Well, we
do
do
is
that
I used
when
to
we
take
go outside.
I used to take a tissue box and cut the hole in it and dig the rubber bands and make the little guitar.
Nice.
My
Okay.
grandma used to say I was so talented. I'm not joking.
All right.
And she'd
So,
give me a hug.
For this week's lab, I think just a discussion will be fine for this week's lab.
Which
So-
lab is that?
I don't know. Some lab in chapter 11.
The first one?
I have no idea. I may not do it exactly the way he does it either. So we'll see. But let's say I've got these three pieces of
Flutes.
pipe. They're about 6 inches each. They're pretty close to the same. Okay. Do you think that they will have the same pitch or a different pitch than each other?
Are they all
Different.
exactly the same?
Like,
They
have
should be
different
pretty well the
metals?
same length.
Oh, different
But they're
metals?
different.
Are they different metals?
materials.
Yep, they're
Different-
gonna have different sounds.
Different.
No.
No,
I think
same.
they'll have same because they're all the same height.
Yeah, they're the
Okay.
same height.
So
It's
who
not
feels
Charles
good about
Dickens.
actually getting a noise out of this thing?
I
I
do.
don't, I haven't played in
I
10
do.
years.
Alright.
I would try to. But okay.
Alright, so we'll try it. Plug the bottom.
I thought you meant this sort of a noise. This is a noise I only. That's the
Yeah, train's coming.
Don't plug your bottom lip. Spread your lips out like this. Your bottom lip is under your top lip. You don't want that. There you go.
Act like you're gonna kiss your mom.
Firmly press it right at the bottom of your lip. This experiment always causes so much trouble.
Oh, I'm getting my head.
It's just
Why are you not getting the right pitch? Don't blow too hard.
You guys have never done that with a bottle before.
It should be
Yeah,
the same
yeah.
pitch.
Yeah, I
It should
have.
be louder.
You don't touch it. Oh,
I've
yeah.
invented my own little mathematical something.
I'm trying to change the sound.
Plug the whole bottom.
You'll blow in it.
No, it doesn't work.
I can change the pitch.
You can change the pitch a little bit. Okay. Yes, we're all practicing with the bottom. Okay. than mine. Why is that?
Maybe the material. Minus there.
Which side did you blow on?
The top.
Alright, so, oh dear, if I do it, listen.
He's like, oh
Like the
dear.
bottom.
Wow, that's terrible. It should be absolutely the same.
Maybe
Well, they're
they're
different.
I don't want to have
They're
to.
Wait, what about this one?
You brought
diameters.
2 bottles, right?
It's the same as this one.
I've got a
Cheater.
malfunction. Something.
Pretty close.
Matt, my frequency is malfunctioning.
This is a lot easier to play. The rolled edge is nice.
We should get.
I think the rolled edge must be our problem. Okay, so the 6-inch
fault.
pipes, no matter what they're made of, pretty much play the same pitch. This is your end. We'll need it in a minute, so keep practicing. Okay, so how about I have a particularly short piece of pipe and a particularly long piece of pipe. What would you
different
expect?
one.
Different.
Different pitches.
Hopefully.
And which one would you expect to be higher than my middle pipe?
The short.
Okay, the short guy is going to be the higher one. Why?
Because you only have a little per frequency pitch. It's little frequency.
Like
I don't know,
lasers,
okay?
yeah.
I don't
Listen to this.
I
Everybody be
just-
quiet. It sounds like lasers. Listen. Yeah.
What's causing the sound?
Or in
This-
the movies when wires snap on like a.
What causes all the sound?
Oh, sound waves.
Yeah.
Sound waves.
Yes,
Well,
is
what
about
makes
to
it
try.
sound?
Oh, the amplitude.
That's
Sound
the
wave.
volume.
No.
Okay, well,
This
everyone
Yeah.
focus in. What
Red.
causes sound?
and the bunch.
Air.
Sound
They
waves.
go
Okay.
together.
So
Oh, I feel
that
dizzy.
thing is doing what to the air around it?
Moving it.
Okay, so
It's like,
thing makes sound, right?
It's breaking the air molecules.
It's not breaking the air molecules. It's oscillating the air molecules. Okay,
Oscillation.
so that thing oscillates.
Oscillation.
It
So-
oscillates the air molecules. Then what do?
They oscillate and spin around and get compressed and rarefied,
Uh-huh.
and then they
And
emit noise.
and how do you hear the noise?
It pumps on your eardrum.
Okay,
And
so
if it
here's
pumps
your
too hard,
eardrum.
will pop.
What's that
I thought it was
called?
cool about the laser on the window and those secret spy guys with the laser.
What do you?
I haven't read the book in like 400 years.
Oh.
Now I read the
Okay,
book.
So
The laser on a window.
I'm just joking.
Laser on what?
You must have read too far.
I never
No.
saw that.
I did not. You
can hear because
You can hear
that window
because-
oscillates.
Yeah,
with,
the window
like
oscillates.
that window. When I talk at it, it does somewhat oscillate.
So if you
because
pointed
of
a
the
laser
sound
at
waves
it
hitting
and
Well, if you were like yelling
you were
at
really smart and
then it
knew
will
how to do
oscillate
stuff,
with a
You're like,
greater
"Yeah, yeah,
amplitude
So you
the
can hear
same
better?
frequency.
you could
yes.
figure out what they were saying.
That's
You
why
out
you
the
could
window.
hear. You
I
could
want a
scream in the
secret,
car
secret-
and you could hear it louder.
super
if you could with the
secret
windows
spy
down.
kits. I
Just
can do
because you're
that.
in an enclosed space. But look, so that slinky is oscillating the air. The air is oscillating until it crashes into my eardrum. My eardrum oscillates, and then it causes the fluid in my inner ear to oscillate, and then it is received by those little cilia in the inner ear, and those guys turn the oscillation into nerve signals, which my brain can interpret and understand as sound, which is way too complex to have been an accident, in my opinion, but you know.
And when you go to a rock concert, it kills them dead.
Not always.
You can kill
No, it
yourself
does
if it-
not.
Yeah,
Oh,
that's-
loud,
After
really
a
loud.
I go to like 70 concerts a year, and now my ears are
I
messed
was
up.
almost
Is that
deaf for
why
like
you
2
can't
days
hear?
after.
You
the
probably,
concert.
you probably
So-
will have ear damage.
Yeah, you
and
can
you
get
I don't
ear
go
care. It's
deaf
worth
earlier.
it.
I don't
don't care
think
when
it's
you're
worth
old.
it. I want to be able to hear when I'm 90.
Yeah.
And be
Yeah,
alive.
I just
And
have to
be
pay
alive.
to concerts now. Then I guess.
They get loud too.
That sounds
It only
You
matters
sit in the
about the
back then.
decibels.
Yeah. What?
Okay, so-
Or when
No,
you go to
I'm
IMAX
begging
and
to
you
stop.
accidentally sit right
Oh,
under the
that's
speaker,
horrible.
it's horrible.
I can't
I was
stand
right next to the speaker.
sitting next to the speakers in theaters.
Yeah, no,
don't
I
like
was
it.
in the
They're
middle.
like-
Like, if you stand in the very front,
That's
not to the left or the right, like in the middle, you can't. It doesn't mess up your ears.
Yeah,
if you're
that's a
like
better
to the
place to
side
be.
by the
Sides are
speakers,
bad.
I was like
you're-
right in front of Dave.
yeah.
Okay,
I
so
usually get up on stage.
why do we predict that
Like,
my
mine's
short
really a
guy is going to have a
Mine
higher
was
pitch?
like my
Ooh,
heart started
because
thumping
it's short.
loudly, and
And
my
what does
ears
that
started
do?
pumping blood, and I was
Uh,
like,
Okay,
That
so
just
short
happens,
pipe,
though.
short frequency, high pitch. Okay,
I didn't know what that was.
short pipe,
I said that.
short frequency, high pitch.
Ooh, look.
How did you get it to work?
The reason that actually works is because it's an octave higher. So the oscillation, this is the normal pitch, but you can play an octave higher if you just.
Sounds like people play the recorder.
My sister plays it in the house and just like.
We all
Okay.
used to have one.
But normal pitch wise, this is going to be higher than that. And obviously this will be lower.
I had a
Make a
friend
song.
that made.
Make
I
a
had a
song.
friend that made one of those out of
Like, well, the way to play a song
bamboo.
truly would be
Little pieces
this.
of bamboo. It was so cool.
I should have brought my flute. It's so much easier. My finger doesn't actually
You can
fit.
turn it
Do you
into like a
actually play
slide
flute?
whistle. And
Yeah, I'm a pretty decent
yeah.
flute player actually. It doesn't plug it completely. Like with a flute, you can plug it and slide and play Mary Had a Little Lamb or
I got
something.
my,
Mary.
I got my
Okay.
brother.
So, now what
Yeah,
we're gonna
we'll just-
do is we're gonna make
Yeah,
some
so
predictions for this lab. Stop playing that. You're gonna pass
Yeah,
out.
it's so funny.
Novice flute. Oh man.
We're going to work for you.
Anyone wanna?
For today's gonna be.
I'll computer lab.
Do you need some paper towels?
I don't know if paper towels are gonna do it. Maybe a baby
industrial
blanket.
strength paper towels.
Yeah. Definitely the baby blanket will be a better choice.
We have.
What's that noise? Is that hot water?
It's gonna be.
Is it like heated something?
It was heated during chemistry a little bit, but thank you. Okay.
Me
No,
and
I
you.
don't.
Yeah.
The baby
See, all
pee
girls
just
know
in.
how to do this.
Oh, no.
Okay. Like, I can.
How to clean up a mess in church carpeting with
Yeah,
that.
we like once.
Last week, in the other nursery,
A week.
this little girl peed her pants.
And it would just be to finish our
And her
song, so-
socks and her shoes and the floor and all over. Not in this room.
Yeah. Okay, so let's make a prediction. Here's what we're gonna do. I've got a set of pipes in this cooler on ice. They're gonna be cold, obviously. I'm gonna heat up a set of pipes and keep one set at a room temperature. So what do you think's gonna happen?
Like which ones are gonna play higher frequency, like higher
Yes,
pitch?
how will, if it's the same length of pipe, then what will happen if it gets hot or cold?
So is this our hypothesis?
So I want two different hypotheses.
Well, if cold slows things down, then it'll be a slower frequency, and that'll be lower pitch. I don't know. That's like a complete guess. I mean, like with lizards, if you put a lizard on something cold, it'll like move slower.
I think that the normal temperature ones will be the middle.
Yes, that's a great hypothesis. Yes. Well, how about
Stop it! Stop it.
What? Sleepy.
how about if I
It's your
make
fault.
this
Don't make
hypothesis?
me cry, you real river. Cold
That
things
pipe
shrink.
is not gonna shrink. It's metal. I think.
Metal
It won't
shrinks
shrink.
when it gets
Metal
cold
does
and
shrink.
expands when it gets hot. That's how like switches work, right?
Oh yeah.
And that's why
Wait,
they
what?
have to make bridges.
So cold things will be
stretchy.
higher,
Okay.
I think.
Oh
Is
yeah.
it a
That's
bit
mine.
shorter,
That's my
higher
hypothesis.
frequency,
Please stop.
or